Now the problem is that there is a sloping surface on which we have kept two masses m1 and m2. The sloping surface makes an angle theta with the horizontal. There is a force of friction between the masses. Let the coefficient of friction for m1 is k1, for m2 is k2. The question is, what is the minimum angle theta for which the blocks will start sliding? And in the next part of the question, what is the force that m1 exerts on m2 or m2 exerts on m1? Now, in order to solve this problem, let us write the force on m2. The first force is the pull due to gravity, a component of which is working along the sloping surface. So that is m2 into g into sine theta. The second force is the force due to friction, which will be opposing the motion of the block m2, and that is equal to the coefficient of friction multiplied by normal reaction, which is m2 into g into cosine theta. And the third force is the force that m2 experiences due to m1, which we write as r, and because it is opposing the motion, let us make it minus r, and the whole will be equal to mass of m2 multiplied by acceleration of m2. Similarly, we can write force on m1, which will be m1 into g into sine theta minus k1 into m1 into g cosine theta plus r, because if we have chosen the force on m2 due to m1 as minus r, the force on m1 due to m2 would be plus r, because the forces are equal and opposite. So this should be equal to m1 times a. Now adding these two equations, we get g sine theta, which we can take common, multiply by m1 plus m2 then minus g cosine theta, which we can take common. Within bracket it will be k1 m1 plus k2 m2. The factor minus r will cancel off with plus r. Therefore we are left in the right hand side with a times m1 plus m2. So we can write the acceleration would be equal to g sine theta minus g cosine theta k1 m1 plus k2 m2 divide by m1 plus m2. Now the blocks will start sliding when a is greater than 0. In the limiting case, when a is equal to 0, we can put a equal to 0 in the limiting case, and that will give us the value of tangent theta equal to k1 m1 plus k2 m2 divide by m1 plus m2. Now we can use the value of a in order to find the value of r. We can substitute the value of a in any one of the equation, either 1 or 2. Let us substitute in the equation 1. We obtain m2 into g into sine theta minus k m2g cosine theta minus r equal to m2 within bracket g sine theta minus g cosine theta into k1 m1 plus k2 m2 divide by m1 plus m2, bracket closed. So we can see that this term, the first term in the left hand side, will cancel off with the first term in the right hand side. So we can cancel them off, and we can write the value of r equal to m2 g cosine theta into k1 m1 plus k2 m2 divide by m1 plus m2 and we have another term. This is minus k2 m2 into g cosine theta. By simplifying, we get r equal to g cosine theta multiply by m1 into m2 within bracket k1 plus k2 divide by m1 plus m2. Now thanks for watching. For any queries or discussions, please contact me at the following email address: Dr. Atish Mazumdar @gmail.com.